Today, I would like to talk about the Toyota Production System, often called TPS. This system changed the way factories work all over the world, and it introduced an important idea that is different from earlier systems, like Ford's assembly line. To understand why TPS is important, we first need to remember what came before it. In the early 20th century, Henry Ford created the moving assembly line. This system allowed factories to produce products very quickly. Cars could be made faster and cheaper than ever before. Because of this, many people could finally afford to buy cars. However, the Ford system had a weakness. It focused mainly on speed and large-scale production. Factories produced huge numbers of the same product, whether customers needed them immediately or not. Sometimes this created large inventories of unsold goods. In addition, workers often repeated the same simple task all day, which could become boring and inefficient if problems occurred in the process. After World War II, Japanese companies faced a different situation from American factories. Japan did not have as many resources or as large a market as the United States. Japanese factories could not afford to produce massive quantities of products that might not sell. This situation led Toyota engineers, especially Taiichi Ohno and Eiji Toyoda, to develop a different approach to manufacturing. Instead of focusing only on speed, the Toyota production system focused on efficiency and continuous improvement. One key idea in TPS is called just-in-time. This means the factories produce only what is needed, when it is needed, and in the amount that is needed. Parts arrive at the production line exactly when they are required, instead of being stored in large warehouses. This system reduces waste. It also helps companies avoid producing too many products that customers may not want. Another important idea in TPS is Kaizen, which means continuous improvement. In this system, workers are encouraged to look for problems and suggest improvements. Instead of simply repeating the same task every day, workers become active participants in improving the production process. For example, if a worker notices that a machine is causing mistakes or slowing down production, that worker can stop the line and report the problem. Then the team works together to find a better solution. This idea is very different from earlier factory systems, where workers were expected only to follow instructions. In the Toyota system, every worker plays a role in improving the factory. Because of these ideas, Toyota factories became extremely efficient. They produced high-quality cars while using fewer resources and less waste. Over time, companies around the world began to study and copy these methods. Today, many industries use ideas that come from the Toyota production system. Hospitals, software companies, and even restaurants sometimes use similar methods to improve their work. In conclusion, the Toyota production system shows that efficiency does not always come from producing more and more products as quickly as possible. Sometimes efficiency comes from producing only what is needed and constantly improving the process. In this way, TPS changed the way people think about manufacturing and management. It showed that workers are not just parts of a machine. They can also help make the system better. And that idea continues to influence modern industries around the world.
All right, listeners, today we're tuning into something that quietly reshaped factories across the world, the Toyota production system. Not a flashy invention, not a single machine, but a way of thinking about work, efficiency, and improvement. If Ford's assembly line was about speed, Toyota asked a different question. What if the real power of a factory isn't just producing faster, but producing smarter? Let's rewind for a moment. In the early 20th century, Henry Ford changed manufacturing with the moving assembly line. Cars rolled down a production line, and workers performed one simple task again and again. The result was incredible speed. A car that once took more than 12 hours to build could suddenly be assembled in about 90 minutes. That system made cars affordable for ordinary people, and it helped create the modern consumer economy. But every system has its limits. Ford's factories were built for one thing, producing huge numbers of identical products. If demand changed or a mistake appeared in the process, the entire system kept moving forward anyway. The line rarely stopped. Speed was the priority. Now fast forward to Japan after World War II. Japanese companies faced a completely different reality from American manufacturers. Resources were limited. Markets were smaller. Companies could not afford to produce millions of unsold products. Toyota engineers, especially Taiichi Ono and Eiji Toyota, looked at Ford's system and asked a bold question. What if efficiency doesn't come from producing as much as possible? What if efficiency comes from producing exactly what is needed? That idea became the foundation of the Toyota production system. The first major rhythm in this system is something called just-in-time. Think of it like a perfectly timed delivery system. Parts arrive exactly when they are needed, not hours earlier, not days earlier. Factories don't fill warehouses with extra inventory. Instead, each stage of production supplies the next stage only when the next stage asks for it. It's like a conversation between machines. One step signals the next step. Production flows only when demand pulls it forward. This reduces waste, saves space, and makes problems easier to see. And that brings us to the second big idea, Kaizen. Kaizen means continuous improvement. Instead of assuming that managers alone understand the system, Toyota believed something different. The people closest to the work, the workers on the factory floor, often understand the problems best. So Toyota gave workers something unusual: the power to stop the production line. Yes, you heard that right. If a worker sees a defect, a mistake, or a machine malfunction, they can pull a cord and stop the entire line. At first, that might sound crazy. Stopping production sounds like the opposite of efficiency. But Toyota believed that fixing problems immediately is faster in the long run than ignoring them and letting defects multiply. In other words, slow down for a moment so the system can move faster tomorrow. Over time, these ideas created something remarkable. Toyota factories produced cars with extremely high quality while using fewer resources and less inventory than traditional factories. And the world noticed. By the 1980s, American and European companies began studying Toyota's methods. Researchers even gave the system a new name, lean production. Today you can find these ideas almost everywhere. Hospitals use similar systems to reduce waiting times. Software companies use continuous improvement methods when building products. Restaurants and retail stores manage supply chains with just-in-time deliveries. The Toyota production system proved something powerful. Efficiency is not only about working faster. Sometimes the most efficient system is the one that constantly learns. And that might be the biggest shift in thinking. Taylor tried to analyze work scientifically. Ford made production faster with the assembly line, but Toyota introduced something new, a system that improves itself. It treats workers not just as parts of a machine, but as observers and problem solvers. So here's the takeaway for today. Factories are not just about machines and products. They are systems made of people, processes, and decisions. When those systems focus only on speed, they can become rigid. But when they focus on learning and improvement, they become flexible and resilient. The Toyota production system shows that the smartest factories are not the ones that never stop. They're the ones that know exactly when to stop, when to fix, and how to improve. So the next time you hear the phrase lean production or continuous improvement, remember the rhythm behind it: less waste, better flow, constant learning. That's the Toyota beat. Stay curious, stay sharp, and I'll catch you on the next track.
Ladies and gentlemen, today I invite you to consider a production system that transformed not only factories but also our understanding of efficiency, responsibility, and the role of workers within modern industry. This system, known as the Toyota production system, emerged in post-war Japan and introduced a philosophy that differed in important ways from earlier models of industrial organization. To understand its significance, we must begin with the systems that came before it. In the early 20th century, Frederick Taylor developed what he called scientific management. Taylor believed that work could be analyzed scientifically, broken into measurable steps, and optimized for maximum efficiency. His approach separated planning from execution. Managers studied the process and designed the best method, while workers followed instructions. Henry Ford later applied these principles in a dramatic way through the moving assembly line. Ford's factories transformed manufacturing by organizing production into a continuous flow of specialized tasks. The system achieved remarkable speed and productivity. A car that once required many hours of skilled labor could now be assembled in a fraction of the time. Ford's achievement helped make consumer goods affordable for millions of people. In doing so, it helped create the modern mass consumption economy. Yet the system had its limits. Mass production relied on stability and predictability. It worked best when factories produced large quantities of identical products. If something went wrong on the line, a defective component or a mistake in assembly, the system often continued moving forward. Problems were addressed later, sometimes after many defective products had already been produced. In this sense, the Ford system prioritized speed over flexibility and learning. After the Second World War, Japanese manufacturers faced a very different reality from their American counterparts. Japan lacked the vast domestic market that had supported American mass production. Resources were scarce. Companies could not afford to produce large inventories of goods that might remain unsold. Toyota engineers, most notably Taeki Ono and Eiji Toyoda, confronted this challenge directly. Instead of replicating Ford's system, they asked a different question. What if efficiency does not come from producing as much as possible? What if it comes from eliminating waste and continuously improving the process itself? From this question emerged what we now call the Toyota production system. At its core lies a deceptively simple idea: produce only what is needed, when it is needed, and in the amount that is needed. This principle, known as just-in-time, ensures that parts arrive at each stage of production exactly when they are required. Rather than filling warehouses with excess inventory, the system relies on a tightly coordinated flow of materials. Each step in the process signals the next step, creating what engineers call a pull system. Production is not pushed forward by managers but pulled forward by demand. The effect is striking. Problems that might remain hidden in a traditional factory become immediately visible. When inventory buffers disappear, inefficiencies reveal themselves. But perhaps the most distinctive feature of the Toyota system lies not in logistics but in its treatment of workers. In many earlier industrial systems, workers were expected to follow instructions without questioning the process. Their role was execution rather than reflection. Toyota challenged this assumption. In Toyota factories, workers are encouraged, and indeed expected, to identify problems and suggest improvements. If a defect appears, workers have the authority to stop the production line. This practice may seem counterintuitive. In systems designed for maximum speed, stopping production would appear to undermine efficiency. Yet Toyota's insight was that allowing defects to continue through the system ultimately wastes far more time and resources. Stopping the line to correct a problem immediately can prevent hundreds or thousands of defective products from being produced later. This philosophy is closely connected to the Japanese concept of Kaizen, or continuous improvement. Rather than treating production methods as fixed, the system assumes that every process can be improved through observation and collaboration. In this sense, the Toyota production system distributes responsibility throughout the organization. Improvement does not come solely from managers or engineers but from the collective intelligence of the workforce. Here we encounter an interesting moral contrast with earlier systems of industrial management. Taylor's system emphasized scientific analysis by experts. Ford's system emphasized mechanical efficiency and speed. Toyota, by contrast, introduces a form of participatory efficiency. Workers are not merely parts of a machine, they are observers and contributors within a dynamic system of learning. This raises an important question. What does it mean to respect workers within an industrial economy? Is respect expressed primarily through higher wages and improved living standards, as Ford believed? Or does respect also require giving workers a meaningful role in shaping the processes they participate in? The Toyota system suggests that efficiency and dignity may not always be opposed. In fact, systems that incorporate worker knowledge can sometimes achieve higher levels of performance. But this insight also introduces new tensions. If workers are expected to identify problems and contribute to improvement, the boundary between management and labor becomes less clear. Responsibility spreads across the organization. While this can empower workers, it can also place new pressures upon them. The expectation of continuous improvement may become a demand for constant vigilance and productivity. Here we encounter a broader ethical question about modern economies. When systems become more efficient and more intelligent, who benefits from these gains? Do the rewards of increased productivity flow primarily to companies and shareholders? Or do they also translate into greater security, autonomy, and well-being for workers? The Toyota production system demonstrates that efficiency can emerge not only from technological innovation but also from organizational design. It shows that factories are not merely collections of machines. They are social systems shaped by relationships, incentives, and shared knowledge. Perhaps the most enduring lesson of the Toyota system lies in its understanding of learning. Traditional industrial systems sought stability. The goal was to design a process so perfect that it would run without interruption. Toyota took a different view. Instead of seeking perfection, it created a system capable of constant adaptation. Mistakes were not merely failures, they were signals pointing toward improvement. This philosophy resonates beyond the factory floor. In fields as diverse as software development, healthcare, and logistics, organizations have adopted similar principles of continuous improvement and decentralized problem solving. Yet the ethical questions remain. A system that learns continuously can become extraordinarily powerful. But learning systems must also confront questions of fairness, responsibility, and the distribution of benefits. In the end, the Toyota production system invites us to reconsider a fundamental assumption of industrial society. Efficiency is often understood as the elimination of human judgment in favor of machines and algorithms. Toyota suggests a different possibility. Efficiency may emerge not from removing human insight, but from integrating it into the system itself. If that insight proves correct, then the true innovation of the Toyota production system may not lie in logistics or manufacturing techniques. It may lie in the recognition that workers, far from being obstacles to efficiency, can be among its most important sources. And that recognition challenges us to imagine economic systems that combine productivity with participation, innovation with respect, and technological progress with human dignity.